There's definitely needs to be those conversations up front about the expectations and how your solution is going to affect things downstream. Ilya, I know you've worked with a lot of different types of companies. What have you found important in those initial discussions when you're scoping out a solution in terms of, probing and finding those situations that might cause issues downstream once you've started integrating a solution? How do you frame those conversations, and what's good to ask up front and establish up front in a project like this?
Well, let's take, for example, price optimization project as an example, right? So typically in this project, it's important to start conversations with business users early and actually structure the whole project in a way that, let's say, after each iteration of the project, you have some sort of a demo or some sort of an educational session for business stakeholders, like for the end, for the end users who will be will use the tool, right, and this model, and this way you kind of gradually educate them before you actually launch the project. And this is like very typical situation that, data science teams or engineering teams, they develop something in silo, some excellent model or whatever it is, some great tool, and then they release this tool, but nobody knows how to use it, and it fails just because business users, they do not support adoption of this tool or this capability in the enterprise. So this is, of course, one of the biggest and most typical challenges.
Yeah, and what's important once you say you create this great model and there is a great use case, there's demonstrated ROI, and you've kind of tried to probe out these questions that might cause issues downstream. That's not the end of the story, because then you release the product, and like you say, people have to use it over time. So what are some good ways, both operationally and maybe data-wise, to what sort of monitoring should be in place over time? How does that influence the kind of longer term of the project? And how do you ensure that you're able to incrementally improve on these technologies over time? Any insight?
One thing that I've seen done, and we built a SaaS solution in the last company that I was at to help companies manage their working capital. And so the whole design was basically writing algorithms and tests to look at different actions that a payables clerk or an accounts receivables clerk could do to improve working capital, and giving them a dashboard to be able to make their lives easier. But then we rolled that up all the way to kind of a CFO level dashboard that shows what's the total working capital improvement opportunity in terms of dollars, and how much of it has been captured and how much of it is yet to be captured, and then kind of ongoing reporting on that metric, to where you kind of know from a CFO's perspective, if he's looking at a problem that's worth $10, $30 million, and he's not seeing the needle move on it, there's going to be some people in the organization that are going to have their heads hit, and they're going to start using the tool to create value. And if you kind of don't have that rigor put in place to drive behavioral change, then once again, it's like there's so many challenges that you have to overcome in order to create value with data science. That's beyond just the data, the feature engineering, and the algorithm. You have to figure out how to get it into production. And in the case where it requires someone to change their behavior, making people change behavior is really hard. To your point, getting someone to enter data into a system, good luck.
So when during a project, because these problems are very complicated, and like if you're working on pricing or something, maybe you've got marketing teams involved, you might have executives, supply chain, you have operations and manufacturing. How have you seen it? Do you have opinions on whether it's better to sort of embed those working on these data science solutions along with the teams working, maybe the marketing team or manufacturing, or is have you seen success with sort of separate data science teams that kind of consult with individual units in a business? Any opinions there from any of you as far as what might bring the most value?
I think the closer the integration, the better. Data science doesn't exist to serve its own need, right? It exists, to solve a real problem, and data scientists are very exposed to very few problems, compared to what a customer or a client or the business is facing. And so I think the closer that integration, the more likely you've solved the right problem and you've really and delivered it in a way that you can take action on.
I've seen a lot of different organizational models blended from the extremes of there's a data science unit that sits by itself in its own silo to every single department has their own mini data science unit, and there's pros and cons to both of those organizational models, and depending on the scale of your company, like my company's not big enough to put several data scientists in each function, so we do have our own data science function. But when it comes back to the project, like the thing that I've seen work the most successfully at both small companies and big companies is when you're working on a big problem to create an agile team around it. So who all is necessary to make this problem be solved? It's more than the data scientists. It might be someone from IT, it might be someone from marketing, it might be someone from operations. Everyone should be in the room together working on the project and aligned on this is something that's valuable for me to spend my time on and for me to prioritize. And if you don't have that traction at the very beginning, it's highly unlikely you're going to get the traction at the end. And you'll just have wasted a lot of time if you don't set that up right at the beginning.
Yeah, that makes sense. So as we're kind of entering into, more standardization around data science, more companies investing in data science, machine learning solutions. I was wondering if each of you could share something maybe that you're excited about in the future and why you think it's going to make a big impact. Ilya?
Well, one thing that I find very exciting is, adoption of techniques like automatic feature learning and reinforcement learning in some of the domains. I think that maybe supply chain and like price optimization, they are not ahead of time in that regard. It most likely at least from what I've seen, it's most likely applies to customer intelligence, but I think it will get to supply chain and price optimization as well. But the point is that these techniques, they actually can transform data science and machine learning very significantly. For example, the current view on, let's say, reinforcement learning and the way how some companies like Facebook approach the problem is that they built a generic platform that is able to consume application logs directly, and then from this application logs, if you write it in the right format, if you have state and actions in these logs, then the platform essentially can learn generic policies, how you optimize interactions with the customers, or how you optimize your pricing, or how you optimize your supply chain, and so on. And this is, this is very, very different from traditional approach to machine learning and data science, that you have all these data scientists and manual feature engineering and this model deployment, right? So it can be a significant shift in the paradigm how you view your data science capabilities, right? The reason why it's probably not that popular in supply chain yet is that reinforcement learning is not, deep reinforcement learning is not geared towards combinatorial optimization, which is the common case in supply chain management and price optimization, and it's not particularly good in that regard, but it's, there are a lot of progress in this direction, so I think that in a few years, many reinforcement learning techniques, they will be applicable to large-scale supply chain problems, and it can change this area as well.
Yeah, that's great to hear. I know a lot of our listeners and maybe the audience here too is maybe they've heard a lot about reinforcement learning or other methods like adversarial methods and other things, and at least personally, I haven't seen a lot of practical applications of those in a lot of companies, like you're saying, maybe because of some of the the problems that they focused on in the past. But it's good to hear that that stuff is coming, and it was awesome to see earlier today in your talk where you've already applied it in a very useful way. So I know that'll be an exciting thing to look for. Chad, what are you excited about?
Yeah, something that excites me a lot is just the explosion of data collection, right? I feel like that was kind of the first challenge to solve, and it feels like that's now taken as a given, right? There's very little pushback on collecting data and storing data. And so I think an interesting area, it was in the last talk, I think where that's going to lead to first will just be, it's too much data anymore almost for a person to understand or to comprehend. And so how can we use machine learning or data science to pull out what are the important pieces of data here? What is the interesting information here? I really appreciated the talk from Gogo. Yeah, I mean, the machine learning wasn't going to say it was an EEPROM polarity. It wasn't going to say that was the problem, but it could surface, hey, there is a problem with this thing. And so I think we'll see a lot of applications like that, where data science is able to pour through the massive amount of data getting collected and pull out what are the parts where, and then really empower a human to make decisions using that. I have a good friend, he likes to use the analogy, we want to make Iron Man, not Terminator. Right? We want to make a superhuman, we don't want to replace the human.
Yeah, I think augmentation is really important to emphasize, more so in a lot of cases than automation. So yeah, that's great. What about you, James?
Chad stole mine, so but I'm just going to riff on that a little bit. Something that I am really excited about is there's beginning to be a growing trend around data consortiums or data aggregators. And I've seen a few now coming out, and I worked with one back when I was at McKinsey, that are basically aggregating tons and tons and tons of public data as well as proprietary data. And then they're building an AI layer on top of it to where you can put in your labeled data that you want to do a prediction on, and it will basically go in and create 1 million different features off of its entire data set in a second and keep creating features until it finds a feature that's correlated with what you're trying to predict. And if you think about kind of the natural data science process, that would be impossible you'd have to have an army of thousands of data scientists to look at all of those many features. And it begins to uncover insights that you would never be able to find as a human. And I think we're just now starting to touch basically the beginning of that using AI to create features. And I think the opportunity there is enormous. And typically what I'm finding is most of the value in a data science use case is driven by data engineering, not by the algorithm that you pick. And so seeing someone solve that problem at scale and bringing more data into the picture, but bringing it into the picture in a way that it's done efficiently is really exciting to me.
It is, yeah. Thank you for sharing those. So I think we built in a bit of time for the audience to ask questions. What I will ask is that you wait for the mic so we can get the question for the podcast as well. So does anyone have a question for the panelists?
How's it going? I know I asked you this question earlier, but wanted to get your guys' take on the future of data science with like auto machine learning and things like that. Like I know you said it's going to be more about data engineering, but just what your guys' take on what the job market will start looking like in the next few years.
Yeah, I think, I mean, certainly there will be more and more powerful tools created. I don't think that replaces the need for somebody to use those tools and to put them into place. And especially because data science, I mean, there's right and wrong ways to practice it. And in a way, the more powerful the tools become, the more important it is to have somebody using them who knows, how to use those tools, appropriately. What's the saying? If you torture the data long enough, it'll confess, right? If you apply too many things at it, eventually you'll find a way that it would predict great, except for it won't, right? When it sees something new. And so, I don't think data science as a skill and as a practice will go away as the tools get better.
I would agree with that. I also think there already is, and there will continue to be kind of a growing trend around data science data scientists starting to act a little more like software engineers, because a lot of the models are just getting dumped directly into software and into automated decision making. And so if you're going to be writing something that is taking in real-time data, making a decision on it, and then sending a signal to something in production to make a decision, then you have to be coding with the same level of fidelity as a software engineer is, because what you're doing has to be production grade. And so that's one area where I think at least a lot of the graduates that we've been interviewing for opportunities at our company don't necessarily get trained on that same level of rigor in terms of thinking about, writing unit testing and doing really proper QA on the algorithms and the codes that they're writing. And I think that's going to be a big change. So I would encourage anyone that's really excited about this field and wanting to grow in it to make sure that you're kind of looking at what are the like modern day software engineering techniques, because those can really apply to data science in a powerful way.
Other questions?
On the topic of demand forecasting, I'm very interested in supply chain alignment, getting your from the customer all the way to your raw material supplier. So one of the things that you mentioned is the challenge that some suppliers will have capabilities to have an advanced analytics team, others won't. Is there a framework, are you familiar with a framework, umbrella framework that will facilitate that process? It's just transferring that demand forecasting probably from one supplier to another one, down the supply chain, that will allow less resourceful suppliers get some sort of insights from that demand forecasting, something like that, some sort of umbrella framework structure, something that will help in that way. I don't know if you're familiar with anything like that right now.
Any thoughts? And maybe part of this has to do with one of the questions I was thinking along with yours is if you don't, maybe you're interested in demand forecasting or whatever it is, and you don't have that huge in-house analytics or data science capability, are there still things you can do? Are people building platforms and other things out there that will still allow you to make progress? Or maybe that's still a wide open field.
From my experience so far in supply chain, there's not a lot of like truly black box, I can just come in and it'll work for me, because every business does operate its own way with its own data schema. So to try to get, in my perspective, to try to get value out of supply chain from a data science perspective and not have someone who has that skill set would be really difficult. In terms of what you're talking about, which is maybe if I put it into like real world terms, like a Danone yogurt company who has a huge like demand forecasting team, but they're buying raw material from dairy farmers that might be highly fragmented. I suppose in theory they could pass the information from their model down to those dairy farmers. They are unlikely to do that unless they feel they're going to get value out of doing that, either through price reduction or through supply chain risk reduction. And so I'm not aware of anyone that's created kind of a software solution to that or is doing that at scale. I know some companies do that, but it's all done kind of in a way word of mouth, right? Your procurement person saying, I talked to the salesperson and I think we're gonna maybe buy 100,000 units in 2 months, but it's not a promise. I'll make it a promise if you give me a 10% discount, but it's not a promise today. I don't know if Ilya, you've come across anything like that.
No, not out-of-the-box solutions, and partly it is explained by the fact that you need to, to typically spend a lot of effort on data cleansing, and you need to have data in a very good shape. But at the same time, there are a number of, proprietary and open source components for, of course, like forecasting in general. And if you have the data in a good shape, then it's typically it's typically, it can be not that challenging to apply these open source components. Actually, in some fields, not necessarily in demand forecasting, but in some other areas, let's say customer scoring, what some companies are doing, they can provide you like industry average score, like under assumption that you are similar to average company in the industry. Then if you provide them with your customer profile, then they can score this customer profile that way, right? So in principle, it can be done maybe for demand forecasting as well, but it depends on what kind of accuracy you expect from it, right?
Other questions?
I myself have been working in the retail industry on a series of models. Let's see, for the right customer at right time, right location, we make the right recommendation with the right discount. So I build models for each of the categories I mentioned. And I created some algorithms myself. But I'm curious, I'm so happy to hear that, the presentation is almost about the retail industry, or the presentations this afternoon. My question is, have you used the existing algorithm in the market? Let's see, K-means, K-nearest neighbor, CAN. So you compare with the traditional ways. Let's see, predicting customers' intention. Let's see, propensity to buy. When the customer steps into a store, so what the customer intend to buy, most likely, the propensity to buy. And then have you done a comparison using a traditional way? Oh, yeah, I kind of predicted that. Let's say you buy some cosmetics and versus you buy some like a drink. So you create two models, one model for cosmetics, one model for, let's see, the drink, something like that. And then you use, let's say, hey, R and C and K-means or whatever the existing algorithm. What I meant is, to me, so far the AI algorithms or the models are not that applicable in the retail industry. And then if you have done some comparison, let's say, hey, I used RNN, I used CAN, it's good, deep learning and machine learning. And then it's, it provided incremental, very significant incremental value. I really care about what kind of incremental value is created by using the fancy, most advanced algorithms. My question is that, have any of you done that?
Yes, so actually we did projects very similar to what you described, like personalization of printed coupons in store. So if you're familiar with, some retail chains, they sometimes have small printers installed, like on checkouts, right? And some companies that operate this network of printers in partnerships with supermarkets, they do personalization models to optimize this coupon. So basically, if you scan loyalty card, then they maintain your profile, historical profile of all their purchases. And even if you don't swipe your loyalty card, and still coupons can be personalized based on your current shopping cart. And typically it works, in our experience, it works reasonably well in the sense that, typically how these agencies work, they provide services to manufacturers of CPG goods. And these manufacturers, they have certain objectives they're trying to achieve, like acquisition of new customers or retention of existing customers or maximization of consumption, like person who typically buys one bottle of cola needs to buy 2 bottles of cola, how to drive him to this behavior. and so on. So, and the metric they use to pay fees to this agency is uplift in volume, or whatever the metric is, like how many customers started to buy more, what's the uplift in revenue. And definitely it's possible to create models that optimize this metric and provide this uplift, at least for some fixed time horizon, right? I assume your question is like how does it play in the long run, right? Can it harm like customer loyalty, or can it impact price sensitivity in negative way? So probably this is I cannot answer. This is very difficult question, but if we are talking about like medium-term time horizon, like is it possible to drive uplift over horizon of 3 months using these targeted promotions comparing to control group, then answer is yes. We've seen such cases in practice, and it works reasonably well.
I had a case that was a little bit, we might have to stretch it a bit to think of how it would relate to retail. But it was working with predicting demand for gasoline and diesel. So the customer in this case would be a gas station, basically, or it could be a fleet of trucks, right? How much diesel are they going to buy for those? And so you're trying to forecast their demand out, and it makes a big difference. You have vastly different amounts of data depending on the customer. There's this sort of small mom and pop station that buys very little. You'll have somebody. You have a retailer who buys a whole bunch because they have a fleet of trucks, right? And so they're constantly, buying a lot of fuel. And so that was a case where actually I had to build a model to classify the type of customer. And then for the customer that buys very little, I would do a rolling average, or I would do a linear trend. As basic as you could get model. Customers that bought a lot of fuel, you could do a boosted tree or something a more complicated form of machine learning. And get better accuracy out of it. And so in that case, it was really about segmenting the customers based on the amount of data, in this case, the amount of fuel that they were buying, in order to decide what level of complexity of a model it would support.
Awesome. Well, thank you, panelists, for the insights. Thank you for the questions. Really enjoyed the panel, and looking forward to the rest of the event.